All right, I'd like to do one last example here. Suppose that we have a company that is manufacturing flash drives. We have the cost, revenue, and profit equations are given by C of x equals 5,000 plus 2x. There's our cost function. R is equal to 10x minus 0.001x squared. There's our revenue function. And profit is, of course, revenue minus cost, where the production in 1 week is X flash drives. If the production is increasing at a rate of 500 flash drives per week, we'll come back to that, when the production is 2,000 flash drives, find the rate of increase in profit. So let's lay out everything that we know here. So let's see, we know that production is 2,000 flash drives. The production output is X flash drives. So that means that X is equal to 2,000. So X is 2,000. What else do we know? We know that production is increasing at a rate of 500 flash drives per week. So this is the rate of increase of production, right? Production is increasing. So that is production output in 1 week is X. So this is the rate of change of X, dx, with respect to time, dt. I can see that it's dt, right, per week, per unit of time. So dx over dt, this is equal to 500. And I can tell it's a positive 500 because the production is increasing rather than decreasing. So I have X, I have dx over dt. I want to find the rate of increase in profit. So if I want to find the rate of increase in profit, essentially I'm trying to find dp over dt, right? This is the rate of change of profit with respect to time. So this is what I want to know. I need a relationship, I need an equation between x and p. So really what I'm looking for is the profit function. I'm going to use my revenue function and my cost function to find my profit function. So over here I know that profit is revenue minus cost. Profit is equal to revenue. This is 10x minus 0.001x squared. So there's my revenue function, minus my cost function, that is 5,000, plus 2x. Remember that we absolutely have to have these parentheses, particularly around the cost function, because I need to know that, oh yeah, I'm going to take this minus sign, I need to subtract both of those terms, not just the first one. So I'm actually going to do that. Let's just change this to a plus and we'll distribute the minus sign to both terms. So my profit function, P, is equal to 10x, let's write this in standard form. Let's see, I've got negative 0.001x squared. 10x minus 2x, I'll have plus 8x. And then plus negative 5,000, I'll have minus 5,000. So this is my profit function, P. I want to find dp dt, which means I need to take the derivative of this function. I'm going to take the derivative of this equation with respect to time t, as I always have in this section. I'm always taking the derivative with respect to time. So the derivative of p, that's just going to be 1 times the derivative of p with respect to t, because I'm using implicit differentiation. I'm taking the derivative with respect to time. I'm using my chain rule. Again, we don't have to write that 1 if you don't want to. If you just want to say derivative of p is dp over dt, that's fine as well. Equals on the right-hand side, derivative of negative 0.001x squared. Well, that's going to be negative 0.002x. But again, we're using implicit differentiation. We're taking the derivative with respect to t. We need to use our chain rule, so I'm going to multiply by dx over dt plus derivative of 8x. Well, the derivative of 8x would just be 8. Again, though, I'm taking the derivative with respect to time t. We're using implicit differentiation. We have to use our chain rule, so we need to multiply again by dx over dt. This one can be a little bit easy to overlook, I think. And then derivative of negative 5,000, well, that's just a constant, so derivative of that part is 0. So I'm looking for dp over dt. I have x, I have dx over dt, I have dx over dt. Let's take the information that we know and plug it in. We should be able to solve here. dp over dt is equal to negative 0.002 times x, that's 2,000, times dx over dt, that is 500, plus 8 times dx over dt, dx over dt is 500. So let's see, I should have, let me multiply this out because I just don't trust my mental math here. I've got negative 2,000 for the first term, plus 8 times 500, that gives me 4,000. So 2,000 plus 4,000, I have a total change of $2,000. Well, I should hold off on that because remember I want to give my unit here, the unit of profit, P, well, I'm probably going to measure that in dollars. With respect to time T, what is my unit of time? We said our unit of time earlier was in weeks. So let's see, it would be $2,000 per week. And I can look at this and I can see, well, my derivative ended up as positive. It's not written there, but really it's a positive $2,000, so my profit is increasing by $2,000 per week. So you might have a question that says, okay, if we increase the production, what happens to the profit? If I'm solely interested in what happens to the profit, right, more profit for me, an increased profit means I make more money. So if all I'm interested in is profit, then yeah, this seems like a pretty easy choice. That means, yes, I should increase my production by 500 units per week because that's going to increase my profit by $2,000 per week. So that seems like a pretty good deal for me.